Now let's learn about some properties of a triangle. First, what we will have to do, we will have to construct one triangle. I have constructed it already for you, in which two sides are equal. For example, AB and AC both are equal to 3.5 centimeters, and the third side BC is 5 centimeters. Right? So, now what does the dimension of these two indicate? They two are equal. Right? So, first I'll write it down for you. Construct a triangle in which two sides are equal to 3.5 centimeter and the third side equal to 5 centimeter. Right? So such a triangle is called an isosceles triangle, where AB equal to AC. Now if you measure angle B and compare it with angle C, what you will find out? The opposite angles are also equal. Right? So this is very important for any isosceles triangle. Right? And how we will prove this? We will prove this by drawing one perpendicular line from A, and it will meet BC at point D. Right? So let us draw a bisector of A of angle A, and let D be the point of intersection of this bisector of angle A and BC. Right? As you can see over here. Right? Now in triangle BAD and triangle CAD, AB equal to AC. This is given information. Right? Now angle BAD equal to angle CAD. This angle BA is equal. How? Because we have drawn one perpendicular bisector AD which is meeting BC line. Right? So these angles BAD and CAD will be equal. So you can write this by construction, since we have constructed this perpendicular bisector. Now AD will be common, right, for both these triangles. So AD is common. Now you can prove that triangle BAD is congruent to triangle CAD by which rule? Side, angle and side rule, right? This is common, and AB is equal to AC is given, right? So we can write it down by side, angle, side congruency rule. Okay, so we can say that angle ABD is equal to angle ACD. This angle ABD is equal to ACD. How we can say that? Because they are corresponding angles of congruent triangles, right? You can write the short form also. Angle B is equal to angle C, right? So now we have proved that this angle B and angle C, they are opposite angles to these opposite sides of an isosceles triangle. What is isosceles triangle? The dimensions of the opposite sides are equal, so they are equal, right? We have proved this theorem 7.2, right? Now let's prove theorem 7.3. What does 7.3 theorem say? It says that the sides opposite to equal angles of a triangle are equal, right? We have to prove this. So how will we do this? For this we will construct one isosceles triangle ABC, in which AD is the perpendicular bisector meeting BC at point D. So you can say that angle BAD and CAD are equal, right? Perpendicular bisector, so you can say that angle ADB and angle ADC are 90 degrees, right? So all these information we get. So now in how will we solve this? In triangle BAD and triangle BAC, angle BAD is equal to angle CAD, because this is given information. This information is given. Now AD is equal to AD, right, of this triangle ABD. This is AD is common side to both the triangles ADC also, so this is common, right? Now angle ADB equal to angle ABC equal to 90 degrees, right? Since it is a perpendicular bisector, this is also given. Okay, now we can say that angle ABD is congruent to triangle CACD. How can we say that? Because of angle side angle, right? This is the angle, this is the side common, and this is the angle. So by angle side angle we can say. We can also say that AB is equal to AC. How? Corresponding parts of congruent triangles, right? Or we can say that ABC is an isosceles triangle, right? We have proved that if the opposite sides are same, AB is equal to AC, then you can say that it is an isosceles triangle, right? Now let's start with exercise 7.2. We'll solve the first sum, which says that in an isosceles triangle ABC with AB and AC both being equal to each other, right? That is, the length of AC is equal to the length of AB, and from B there are one perpendicular bisector from AC. I mean to say from AC there is one perpendicular bisector, right? And from C also you can draw a bisector which will meet AB at point E. Now where they meet you can call that as O, and you can join AO, right? Now we have to prove that OB is equal to OC and AO is bisecting angle A. We have to show these two results. So how will we start? Now in ABC, what information is given in this triangle AB equal to AC? It is given. Now so you can say that angle ACB equal to angle ABC, right? These two angles can be same. How? Angles opposite to equal sides are equal. We have just proved. So we will write it down, because angles opposite to equal sides are equal, right? Now if you add 1/2 on both these sides, what will be the equation? Now half of ACB is what? ACO, since C is being bisected, right? So we can write, instead of ACB we can write of half of ACB as ACO, angle ACO equal to angle ABO, right? This we have to write the reason for that, because OB and OC, right, these both are bisect angle B and angle C respectively. Okay, now in triangle ABO and triangle ACO, AB equal to AC, right? AB equal to AC, this is given, and angle ABO equal to angle ACO, this is proved above, right? Now AO is common, right? AO is common for both ABC and ACB. So you have to write it because it is common. So now you can prove that hence triangle ABO is congruent to triangle ACO. How we can say that? Because of side congruency rule. Okay, and OB will be equal to OC. This OB will be equal to OC. How? Because of corresponding parts of congruent triangles, right? And angle BAO equal to angle CAO. This can also be proved by corresponding parts of congruent triangles, right? When BAO is equal to CAO. You mean to say that AO is the bisector of angle A. So you can write that hence OA bisects angle A, right? Now let's solve problem number 6. ABC is an isosceles triangle in which AB is equal to AC, right? Any isosceles triangle has its two opposite sides equal and side BA is produced. It is extended in such a way that it will end at point D such that AD will be equal to AB. That means these two dimensions, dimension AB will be equal to dimension AD, right? You have to extend this A such that these two dimensions will be equal. Now it is asked that you have to prove BCD is a right angle triangle, right? So how will we start about it? First we will consider this triangle ACD, right? We will talk about this ACD in which AB is equal to AC is given. AB is equal to AC. This information is given. Now angle ACD equal to angle D, right? Or ADC you can say, right? ACD and ADC are equal. How come they are equal? Because when this side is equal to this side, it is an isosceles triangle and opposite angles are equal. So you can write that angle ACD equal to angle ADC because angles opposite to equal sides are equal. We have proved this in theorem. Now if you consider triangle ABC, AB will be equal to AC, right? This is also given. Angle B equal to angle ACB. How can we say that? Because angles opposite to equal sides are equal, right? Now in triangle DBC, angle D plus angle B plus angle BCD, right? Angle D and angle B and angle BCD, if you add all these three, the sum will be equal to 180 degrees, right? Now instead of angle D, we can write angle ACD plus angle ACB equal to, here will come ADC, right? ADC plus angle B, this is angle B, and plus BCD, that is all these three angles will add up to 180 degrees. Now instead of angle ADC, we can write ACD since they both are equal, right? So we will replace ADC by ACD. So we have replaced ACD, right? Angle B can be replaced by angle ACB since they both are equal, right? and you will find the angle BCD. How will you find? It will be equal to 180 degrees minus angle BCD. Now ACD and plus angle ACB. If you add these two angles, it will be angle DCB, or you can call BCD, right? So this will be angle BCD, and this you can bring it on the left hand side. The sign will change, minus will become plus. So this will become twice of angle BCD equal to 180 degrees. Now if we solve this equation, we will get the value of angle BCD as 90 degrees. So you can say that angle BCD is a right angle, right? Now let's solve sum number 8. Show that the angles of an equilateral triangle are 60 degrees each. We have to prove that an equilateral triangle has internal angles of 60 degrees each, right? Equilateral triangle means it has 3 vertices, right? So first of all, what we will do, we will draw one triangle, right? We have drawn this equilateral triangle, means all sides are equal, like AB is equal to BC is equal to CA. All are equal to 3.5 centimeters, right? Now in triangle ABC, AB is equal to AC. This is given, right? And angle C is equal to angle B. How can we say this? Because angles opposite to equal sides are equal, right? These two sides are equal, so these angles will be equal. Understood? And similarly, AB equal to BC. This AB be equal to BC. This is also given, right? So angle C will be equal to angle A, right? Same reason, because angles opposite to equal sides are equal. Okay? Now first of all, you name this as equation 1 and this as equation 2. Now from equation 1 and 2, we have angle A equal to angle B equal to angle C, right? All these three will be similar, because angle C is equal to angle B and angle C is equal to angle A. So angle A will be equal to angle B, right? You remember Euclid's axioms? We have learned in the chapter number 5. So if we add all these angles, angle A plus angle B plus angle C, their sum will be equal to 180 degrees, right? Now if instead of angle B we write angle C, and angle C is equal to angle A, so we can replace angle B with angle A, and in place of angle C also we can replace angle A. So if we add all these three angles, the sum should be 180 degrees. Now 3 times of angle A equal to 180 degrees. Therefore, angle A can be written as 180 degrees by 3. So, when we solve this, we will get angle A as 60 degrees. So, angle A equal to angle B equal to angle C equal to 60 degrees. Right? We have proved all these three angles is 60 degrees. Okay.